Water, such an essential component of our daily lives. It's considered the one fuel that powers everything, from protecting public health and safety to influencing economic growth. An adequate water supply must be available to fight fires and sustain local businesses in our community. Take a moment to consider its value and importance.
Well, without fresh water, obviously we wouldn't have water for the water fountains for our customers coming in. We wouldn't be able to serve our soft drinks because they're all mixed with water. We wouldn't have any restroom facilities. And on top of that, the air conditioning wouldn't work because it uses a water cooler. So in the summer, it'd be pretty miserable in here.
Clean water is very important to the hospital and Conn Health. Infection control is incredibly important. We need to take care of our patients and make sure that our facilities are clean. We need to have clean water so we can wash our hands, sterilize our equipment, and make our environment safe for the citizens of Guilford County. In addition to that, there are over 800 dialysis patients in Guilford County that Conn Health and other dialysis facilities provide services so that they can live. Clean water is fundamental to that, and they could not live without clean water.
Water is obviously essential to the restaurant industry and the brewing industry. You start your day off, you wash your hands, and then you're brewing a pot of coffee that you're going to need some water for. Then, you might have to wash some things down, either whether it be dishes or equipment or what have you. Obviously, we're in the hospitality industry, so we have serving water is an everyday occurrence. Pretty much every table gets at least a glass of water. The staff, they need to stay hydrated as well, so they're drinking water. All of our dishwashers, the machines, they're running on water. Clean up, washing floors, washing down any of the equipment, that's going to require water use as well. And then really the most important thing is we are producing beer. And beer is probably the most essential part of the brewing process. As far as without the water, you're not going to have the liquid, you're not going to have the beer. Yeah, we're going to add all kinds of really nice ingredients with the hops and the barley, and where there is a process, of milling in and the entire brewing process to make the beer, but without the water, beer is not going to exist.
While there's nothing really glamorous about tap water, it's our pride and joy. Our special delivery to you, our customer. In addition to providing quality water, we also collect wastewater and treat it to make it safe for returning to the environment. We are the City of Greensboro Water Resources Department, a group of professionals dedicated to ensuring that your water and sewer services meet your high standards. Let us introduce you to the systems and the people who consider your water and wastewater priority number one. Let's start with water. In 1882, work was started on a city water system. Pipes were installed downtown, and a lighthouse-shaped tower near the end of South Elm Street provided the storage and the pressure needed to force water through the pipes. The original Greensboro water plant, which was constructed on the site of the current Mitchell Water Treatment Plant, originally drew water from the adjoining North Buffalo Creek. Drought conditions and increasing population prompted the city to create additional water supplies to quench its growing thirst. In 1926, Lake Brant, Greensboro's first man-made reservoir, was constructed. In 1958, Lake Brant was enlarged and Lake Higgins was constructed as a second reservoir. Lake Townsend, the city's largest reservoir, was completed in 1969.
Over the last 15 years, the state of North Carolina and the Triad region has seen multiple droughts. The city of Greensboro has learned quite a bit and has responded to those droughts in many ways that the state of North Carolina's Division of Water Resources has given us accolades and said that we have taken the right steps in the right direction.
Anticipating future needs, the city joined other jurisdictions to form the Piedmont Triad Regional Water Authority in 1987. However, water from the resulting Randleman Lake would not become available until 2007.
Well, Greensboro established a relationship with its regional partners, and those regional partners built the Piedmont Triad Regional Water Authority. Greensboro has 53% ownership or interest in the authority. The water treatment plant came online after Lake Randleman was filled. That treatment plant came online in 2010.
Existing water supplies sustained the city until the late 1990s, when a severe drought threatened the region. Greensboro responded by taking steps to reduce its water supply vulnerability.
In response to the multiple droughts and capacity issues, Greensboro forged ahead and established contracts with its neighbors, interconnecting our distribution systems so that Greensboro could purchase finished drinking water. Those interconnects were established with the city of Reidsville to the north, the city of Burlington to the east, and Winston-Salem to the west. Winston-Salem's is an emergency interconnect without a contract. Another resource that Greensboro was able to put in place was reestablishing a pumping station on the Haw River so that raw water could be transferred from the Haw to Lake Townsend in response to low lake levels following a drought.
So, how does lake water become safe to drink? The first step begins before the water ever reaches the lake. The management and protection of stormwater is an essential element of resource management.
The stormwater program in the city of Greensboro started about 20 years ago when we had a federally mandated permit for the National Pollutant Discharge Elimination System, or the NPDES permit for short. All the big cities around North Carolina and around the country had to start, anybody over 100,000 people had to start different programmatic measures to address stormwater runoff. So our program started in 1994, and we've been doing programmatic measures such as a bioretention facility or other measures to improve water quality and manage stormwater runoff ever since.
Stormwater is the water that runs off the surface of the land when it rains. As this water travels, it picks up pollutants from man-made surfaces and carries it to our streams and lakes. The more we can manage the quality and amount of this water, the cleaner our drinking water source can be.
Stormwater is managed in multiple different ways. We primarily look at water quantity and water quality, and there's different ways to manage both. This device we have here behind us, this bioretention facility, or what we commonly call a rain garden, manages a little bit of both. So it takes the runoff from the parking lot, detains it or captures or intercepts it here, and treats it as well as the detention before it releases to the downstream receiving waters, in this case a creek and a lake.
The proactive management of stormwater goes beyond just controlling the rainwater. Studying and monitoring our streams through water quality testing gives us an early warning system to any problems that may make its way to our drinking water source.
We find it important for multiple different things. Primarily, protecting our local streams allows the natural resources to maintain their maximum potential, but also the streams feed our drinking water lakes. And so the cleaner the streams are, the cleaner our lakes are, which means less treatment for our drinking water and thus cleaner drinking water.
Greensboro operates 2 surface water treatment plants, the Townsend Water Treatment Plant near Bryan Park and the Mitchell Treatment Plant at the intersection of Benjamin Parkway and Battleground Avenue. These treatment plants pull raw water from 3 main sources, Lake Higgins, Brant, and Townsend. The raw lake water is pumped into the plant where it is treated to remove clay, silt, and harmful pathogens. This removal and extensive treatment process is monitored by plant operators and laboratory personnel. Before the water is provided to our customers, additional treatment is needed for disinfection, pH control, corrosion control, and fluoridation. This ensures the water meets state and federal regulations and is safe for distribution. Even after the water has made this incredible journey and enters the distribution system, the quality of the water continues to be monitored to make sure that when it reaches your tap, it's safe and of the highest quality. Operators also monitor pressure levels within the distribution system to make sure water reaches homes, businesses, and public safety needs, like water pressure for fighting fires. The process of water treatment does not end once the water leaves the facility. Regular bacteriological tests are used to monitor the quality of the water in the system. Additional data is collected through tank levels, lake levels, and rainfall totals. Monitoring the system on a daily basis helps keep the quality and the delivery of water consistent for everyone who depend on it. Both plants are equipped with certified labs that make sure water quality requirements and drinking water regulations are met.
There are about 120 substances that we monitor regularly throughout the year, but there are also ones that we run daily, such as a bacteriological test, and that is just to make sure that we are providing the best quality product we can for our customers. Our tests are performed in a couple different locations. Many of the tests are performed either here at the Townsend lab or at the lab we have at the Mitchell plant. But we also analyze some samples out in the field, and we run those in places such as schools and fire stations. And we also check the raw water quality out on the lakes. We check the water every day. It's checked throughout the whole treatment process, it's checked as it's leaving the plant, and it's checked out in the distribution system. The work we do here in the lab is extremely important. It's our responsibility and our mission to protect public health by making sure that we're supplying a safe and high-quality drinking water for all our customers.
The technology of these facilities and the expertise of the staff play a vital role in the city's proactive approach to providing quality drinking water for our customers. Once the water is treated and is ready to be distributed, massive pumps are used to move the water from the treatment plants to the system of pipes throughout the city. Within the water distribution system, many water storage tanks and water booster stations help to ensure water reaches our customers. Nearly 1,500 miles of underground water lines span across the city delivering drinking water. That's about the distance from Greensboro to Denver, Colorado. And the majority of these water lines have been in the system since they were first installed. 46 miles of water line located in the heart of downtown were installed prior to 1925.
The earliest recorded history we have on the pipes in the downtown area are 1901. I've heard from some of the older guys in the system that they were in the late 1800s, but we started recording history in 1901 on our maps. And just to put kind of in perspective how long ago 1901 actually was, how long that water line's been in service and is still in service. Oil was first discovered in Texas. Walt Disney was born, Queen Victoria died, and our 25th president was assassinated in 1901. So that's a long time. That's a lot of names you don't hear common, and that water line's been in service for a long time.
Water main breaks happen, and the system needs regular maintenance to ensure its reliability.
I work on the city's water infrastructure. We maintain, repair, and just make sure the city's water is flowing sufficiently. Usually it's usually a maintenance, sometimes emergency. We get called, just like with the situation we're in now, it's a valve that's been leaking. We definitely don't want water just oozing out in the street, so we repair our valves or our mains pretty much immediately.
Each year, Greensboro spends millions of dollars to replace or rehabilitate aging water lines.
Water rehabilitation is the process used to restore old water lines to conditions similar to that of a new water line. Tuberculation occurs inside the water line due to the manufacturing process used in the early turn of the century. The pipes were unlined, therefore basically allowing rust to develop inside the pipeline. Epoxy lining is another method of water rehabilitation that we perform. It's a process used where we clean and scrape the tuberculation buildup inside of the pipe and then spray an epoxy lining inside of the pipe to prohibit the growth of tuberculation from reoccurring. And also pipe bursting, where we pull a new water line in through the old water line. We need to rehab water pipes typically to extend the lifespan of existing water lines which have already exceeded their expected design life. Water rehabilitation can also be utilized to increase the size of an existing water line in order to meet current or future demands.
The ability to manage such an important resource and meet the demands of new regulatory mandates takes the combined efforts of multiple systems and dedicated professionals working behind the scenes to manage our water needs. Just like many water utilities across the nation, the need for replacement of aging infrastructure is a growing concern. The management of our distribution system poses challenges from both an operational and public health standpoint.
What lies beneath our feet, people don't think about on a regular basis. And so what's gone on is that those pipes have lain below the ground for some of them 100 years, more than 100 years. And what we now are facing is about $635 billion nationwide of investment that's required to repair and replace and renew those pipes. The other thing is that people aren't aware that for the people who maintain and work in our water infrastructure, the requirement for additional training, knowledge, skills, and abilities, as our understanding awareness has grown, is much greater. So the professionals who have to be involved in maintaining that infrastructure need much more knowledge, much more skills, and that's an investment that the public also has to be prepared to make now. And right now, about 1 gallon out of every 4 is lost in leaking pipes before it reaches the tap. And it also means that water that's lost isn't available as a product for our industry and our businesses to use. It takes millions of gallons to manufacture wafers that are used in the silicone industry. It takes millions of gallons to produce steel for automobiles. It takes millions of gallons, whether you're in agriculture or you're in clothing manufacture or you're a food producer. Those gallons of water we can't afford to squander or waste. We need to make sure that those are available to ensure that jobs and industry thrive in our communities.
The City of Greensboro actively pursues proactive approaches to infrastructure maintenance through risk assessment as part of their asset management program.
Well, risk assessment is part of our overall program of asset management. It's basically a way for us to look at our infrastructure, in this case our distribution and collection system, and determine what the condition of it is. And based on that condition, we can get an idea of what the risk is of potential failure of that system. And it's very vital, obviously, the distribution and collection system is vital to maintaining sustaining our community, basically, and the vitality of our community. So without an idea of what the risk is, we run the potential of having service interruptions. We also run the potential of having water quality issues and ultimately impacting public health. So risk assessment is very important. It's an overall process of our asset management program.
Based on their work and efforts, we continue to gain information on the condition of our infrastructure through the implementation of technology. In order to make this happen, our men and women in the field work hand in hand with additional support teams, providing everything from customer service, engineering and planning to inventory and equipment repair. You've seen the crews and what they do, and it takes a lot to support them. At the warehouse and equipment yard, all the materials they need are at hand and are ready to go.
We stock the warehouse with essential maintenance items for the municipal system. Pipes, valves, fittings, anything that we could need for emergency repair or routine maintenance. And we service lines anywhere from a 1/2 inch to 72 inch out in the system, so we need to maintain a robust inventory.
The most valuable asset to efficiently managing a system of this size is data. Information about what needs to be changed, what will need to be replaced, and when that should happen. Data is managed for maintaining inventory and processed to be used for decision making.
We gather data from the field through many different avenues, through high resolution videotaping of our sewer mains, through maintenance records of our water mains, and we compile all this data along with some information from consultants. We compile it and we use that information to determine likelihood of failure, and we use that to prioritize our maintenance and repair.
They're going out there and they're looking at how the system is operating, and then they're assessing it, and they're bringing that information back, and then we as a department, whether it's engineering, whether it's business, whether it's operations, or even water supply, water reclamation, we come together as a group and we make decisions based on that information. And a lot of that drives our capital improvement program, whether it's at the plants for the water supply, water reclamation, or it's in the distribution and collection system. So that information that they're collecting is vital for us to make good, informed decisions about how we maintain and improve and expand our system going forward.
The records of all this data end up here.
Data is managed through a database system, Microsoft SQL Server. Also, we collect data in various other formats such as Excel and Microsoft Access. But ultimately, all data goes into the main database on our servers. Data is used for reporting both on a local, state, and federal level. It's also used to improve business processes for preventative maintenance and for capital improvement projects.
So a service call, such as a water main break or sewer backup, is also an opportunity to gather information to help us learn from the past with an eye on the future.
When we have a main break or we have a sewer overflow, that's an opportunity for them to get out into the field and do an assessment of the situation, look at the risk, and also determine in this instance why the failure occurred. So absolutely, operations is probably our forefront. They're at the forefront determining what the condition of our system is, and it's a good indication. Their maintenance activities, their operational activities, their visual inspection gives us a very good idea as far as what the risk is associated with that line, whether it's a water line or a sewer line. So,
our job is the stewardship of the city's investment in the two main systems that make up its infrastructure.
We are, one of the core values is stewardship. So one of the most important things we can do is to make sure, because of the financial implications tied to those systems and the amount of money that we've got tied into them, it's very important for us to utilize good stewardship in making sound decisions so that we can maintain the system going forward.
We've seen how water is treated and delivered to homes and businesses in the city. But what happens to that water when our customers are finished using it? Collecting, transporting, and treating all the wastewater produced is an entirely different system. Some of the challenges being addressed within the water system are also present within the sewer collection system, which is the series of pipes that transport wastewater to the wastewater treatment plant. This system dates back to 1928, which was when the first treatment plant was constructed. Pipes were installed to transport wastewater to the treatment plant, and some of the older pipes are still in use. The South Buffalo Creek Treatment Facility was the first plant constructed in 1928 to serve Greensboro's homes and businesses with a capacity to treat 4 million gallons of wastewater per day. As the city began to grow, so did the need for treatment of wastewater. This led to the construction of the North Buffalo Wastewater Treatment Facility in 1938. Both facilities were expanded to meet additional capacity needs, which continued to grow, and in 1984 the T.Z. Osborne Water Reclamation Facility replaced the South Buffalo Creek Facility. Today, nearly 1,400 miles of underground sewer lines and about 50 lift stations transport wastewater from our customers to the treatment facility. With these aging sewer lines, regularly scheduled maintenance is used to prevent leaks and blockages.
Well, what we do when we flush and clean the city's collection system, sewer collection system, we have old terracotta pipe which will develop a cavity, and we also have the slip liner, which is a plastic pipe. It's good about collecting grease, so we have to keep the collection sewer system flushed out so it won't bag up in your home or a manhole won't overflow. We have a PM book which has different streets on it. Basically what we do, a line that has, we've had a blockage or a manhole that has overflowed, we'll put it on a PM, a maintenance schedule. We have lines around restaurants where there's a lot of grease, so we just have to keep them flushed out on a day-to-day basis. The lines we clean, we turn in a daily log, and everything is logged. Every line we clean, every blockage is on a log, and then we go to our laptop computer systems and we update them on a day-to-day basis.
Regular maintenance is needed to ensure the system's reliability.
We repair the sewer services and the sewer mains. A lot of it is because of roots and grease and the age of the pipes.
Much like water distribution, millions of dollars are needed annually to replace or rehabilitate aging sewer lines. Deteriorating sewer pipelines caused by leaks, cracks, and root penetration can result in major issues within the system, known as sanitary sewer overflows, or SSOs.
Sewer rehabilitation basically is a process where we take the existing lines that we've got and replace them without having to dig them up. Most folks call that a trenchless technology. One of the reasons we do it is it's a lot less impact on our residents. Cost-wise, it's about equal to dig and replace, but the disruptions that we cause are much less significant, and it allows us to put pipes that perhaps have a useful life of 100 years back in place of pipes that have outlived their useful life after 50 or 60 years. There's a couple different ways we prioritize lines. Some of it's strictly by maintenance. Our maintenance personnel will come out and work on a line based on a grease stoppage or root intrusion or a collapse. And then as of the last few years, one of the things we've done is gone out and done some significant modeling in our system where we stuck some monitors in the sewers and determined how they reacted when we got rainfall. And some of the areas, this one being one of them, when we get significant rainfalls, we see a significant amount of water enter the sewer system that's not supposed to be there. So we took the time to break the basin down into smaller increments, determined where we think the leaks are, did some additional investigation, and prioritized work based on that. Well, we actually use 4 methods. The first one is slip lining. We take a smaller diameter, high density polyethylene liner and just pull it inside the old pipe. Because the pipe is so much slicker, it'll still carry the same amount of water as the hose pipe. It's the least expensive method, and in most cases that's what we use. The other process we use is called pipe bursting. It uses the same material, but in this case it allows us to pull in a pipe that's as big or even larger than the hose pipe. We use a pneumatic hammer that breaks the old clay pipe out of the way and hauls in the new plastic pipe behind it. We also do cured in place pipe. That is a process where we use a felt impregnated sock that is heat cured that adheres to the side of the hose pipe. And then the last method we do is actually we do some small places where we have to do some dig and replace.
In some parts of the sewer collection system, sewage must be pumped into a neighboring basin. This is achieved through the use of sewer lift stations.
Lift stations make up part of our wastewater collection system. When we collect wastewater from industrial or residential customers, typically the water will flow by gravity in a sewer main to the treatment plant where it can be treated. In some cases, in low areas, water cannot flow by gravity, so a lift station is put in place to elevate that water from that low area and pump it up, and it may pump straight to a treatment plant or pump uphill to a gravity main.
The department carefully evaluates sewer lines through our TV inspection program to determine which lines will be suitable to receive rehabilitation over replacement. During the process, a small robot-like camera is lowered into the sewer main to instantly provide a view of the current line.
We use a remote-controlled digital camera that we put in the sewer lines or storm lines, and what we do, we visually inspect all defects that are in that pipe. Some of the defects that we find are roots, busted pipe, infiltration, which is unwanted water that's coming into our collection system. Some of the problems are just age itself. Some of them are poor installation, which over a period of time has deteriorated. The information we capture is we take all of these defects and we list them by severity, and we make recommendations to repair all of those in order of importance. Once we find these problems, we're able to be proactive on fixing these problems rather than wait for problems to get worse over a period of time. So this camera basically pays for itself in the proactive recommendations for repairs.
After arriving from one of the neighboring basins, sewer flows by gravity to a water reclamation facility. Currently, the capacity of the remaining facilities is 56 million gallons per day. Similar to the water treatment plants, which take raw lake water and make it safe to use, these reclamation facilities take used water or wastewater and process it so that it's safe to put back into the environment.
We basically are farmers. We grow microorganisms, and those microorganisms are what treats the wastewater. We're doing exactly what the streams used to do before there were wastewater plants. The algae that grows on rocks have microorganisms, and those microorganisms are what treats and cleans the waters that are already in the streams. As civilization grew and the streams were unable to clean themselves, then we came up with wastewater plants. This is a standard influent wastewater that comes into a plant, and you can see it's a gray color, and you can see some solids in the bottom if I move it. That is your everyday wastewater, and that comes in, and part of this is food and part of this will get wasted to the landfill. And this is our activated sludge. This is our actual growing of the microorganisms. What you see settled out in this here is the microorganisms in our sludge. And then we have to add oxygen, and we have to keep them mixed up to keep them alive. We have to provide a nice home for them and keep the oxygen levels at the right level to keep them alive and to do their job and stay active. And then once it leaves the activated sludge basins, it comes to our final clarifiers. Once it leaves there, it leaves as a cleaned effluent. And this is actually what goes into the stream after our disinfection.
Reclamation facilities are large, complex systems that use physical, chemical, and biological processes to clean the wastewater.
Daily we sample for BOD, suspended solids, ammonia, fecal, DO temperature, pH. We do some metal samples daily. Yearly we do about 48,000 samples that are analyzed. We collect over 10,000 samples a year. And we just purchased a new metals machine for trace metals, and that will add about 10,000 samples a year that will add to the 48. The majority of the tests are performed here in the laboratory. There are some tests that have a 15-minute hold time and must be performed in the field. Dissolved oxygen, pH, and temperature have a 15-minute hold time. So when we get creeks, we have to run those on site, and some of our industry samples must be run on site as well. We do our best to comply with our NPDES permit that is given to us by the state and EPA. We tell our operators how well the plant is working, if adjustments need to be made. We very rarely ever have a permit violation because it runs so efficiently. We have a good relationship with operations. They're able to come to us, we can go to them. We sample industries and can bring new industries to Greensboro based on something Marty put into effect, a pollutant trading system, where if an industry needs a certain amount of a pollutant and another one doesn't, we can trade that out in their permit so that it gives them a more of an allocation. So we keep the waterways clean. We do the best we can to ensure that everything we do is correct and environmentally safe.
The quality of water released into the environment is held not only to state and federal regulations, but to our own. Our responsibility and stewardship of this important resource extends beyond our city to our environment as a whole. Moving forward, the Water Resources Department will continue to advance its proactive approach in managing the city's infrastructure by increasing the percentage of infrastructure rehabilitation and replacement efforts. Another large part of our strategic planning includes managing and evaluating the operational efficiency of our system and always developing new tactics for water resource sustainability.
Operational efficiency is important to the business model of the Water Resources Department. It's a philosophy that embodies the benchmarking or doing a comparative analysis of how we're doing against that of other water utilities like ours of like size. We also want to make sure that we're doing a good job of risk analysis and condition analysis of our underground and buried assets. To do so allows us to do a good job with capital planning and operations and maintenance management so that we place the dollars where they need to be strategically. Place the dollars on the pipes that need the attention first.
Education and outreach is also an important part of our job. To manage a resource this important and react to a system this complex on a daily basis only is just not good enough. We strive to manage the system daily, but plan and prepare for the future. We work to identify and take the steps necessary to ensure the well-being of our resource and this system for years to come.
In addition to strategies for improving operational efficiency of our utility business, perhaps the most important tool that we can use is how do we communicate with our public and our elected leaders who support the utility, the assets that they own. And we need to do an effective job at that so that our ratepayers understand what it is that they're helping to take care of as good stewards. When we do ask for a rate increase, where does that money go? Why is that important? Why is it important to the economic vitality of our city? The work of the men and women of the Water Resources Department is incredibly important and responsible work. We are made up of many people doing many important things in the areas of science, be it chemistry and biology, engineering, folks in operations 24/7 in our water and wastewater treatment plants, the people who maintain the plants and the water and wastewater lines, administration, customer service, helping people get their water service or answering questions on how to pay for the water service. I could go on and on. That is the most important asset of our Water Resources Department, the people and the service they provide.
We are the City of Greensboro Water Resources Department, a dedicated group of professionals who will continue to work hard to ensure that your water and sewer services meet your high standards. And we are proud to serve our customers, the citizens of Greensboro.